My name is Gilad Rozen. I'm the CEO and founder of Celeno. We're doing very innovative Wi-Fi technology. And over the next 7 minutes, maybe 6 minutes and 50 seconds left, I'm going to present you with our growth story. So, at a glance, we're a leading provider of smart Wi-Fi technology. And we're doing both silicon chipsets, we're doing edge software, and we're doing cloud analytics. So altogether, 3 components with which we are providing our customers with comprehensive solutions. We're a privately held company. We're deployed, maybe I'll switch to this one. We're deployed with, it's okay? Working, okay. Deployed in tens of millions of homes worldwide. And our investors include, as you can see here, some financial guys, including, of course, OurCrowd, as well as some strategic investors such as Aris, Liberty Global, and Cisco. We're based out of Israel with operations in Europe, both the UK, France, United States, Greater China area, Taiwan and China, and Korea. And I think the interesting thing is our growth strategy. So we're targeting with our offering multiple market segments, including service providers, enterprise, smart home, smart city, smart building, retail, automotive, and Industry 4.0. And the product offering with which we're addressing those markets are comprised of connectivity, Wi-Fi imaging, and I'm going to spend some time on that throughout the presentation, and positioning technology. 3 components folded into one product offering. I want to talk a little bit about the challenges which are characterizing the Wi-Fi domain. And I think the numbers that I'm going to show you now are quite overwhelming. I don't know if you know, but by the end of 2017, there has been some 9 billion Wi-Fi devices worldwide. And in 2017 only, there are about 3 billion devices that have been shipped to the market. And the numbers keep on growing. So the trend is more and more and more Wi-Fi devices. The use cases are quite diverse. It's about video, it's about data, it's about voice. And all of that is trying to operate based on a technology that has been invented some 25 to 30 years ago. And the conclusion is what we can see here: Wi-Fi has become strained beyond its capability. If you want to look at that in some kind of an illustrative way, so we can think about cars representing data packets, and the difference between what we do and what's happening in the market is about random behavior, collisions, actually tons of congestion, versus virtual lanes, managed traffic, which enables you to create and to support the various use cases with plenty of devices used across the home and in enterprises. Where are we deployed so far and what is our status? So we are today, as I said, in tens of millions of homes worldwide, both in Europe, in Asia, North America, worldwide. What's the whole thing about Wi-Fi imaging and the product strategy that we have today? So people typically think about Wi-Fi as some kind of means to do connectivity, to connect their devices, to connect laptops, tablets, smartphones, TVs, and so on to the network through routers. But the thing that we have added is actually the ability to do what we call 4-dimensional Doppler imaging based on Wi-Fi technology. So we're actually leveraging the fact that Wi-Fi transmission is based on radio waves, same thing as radar systems. We're transmitting and receiving back and analyzing the differences, and with that we can detect things like body postures, for example, fall events, positioning of elements, gestures of people, vitals, whether a person is breathing or not, for example. And we can do that without the need to have a Wi-Fi device at the client. So whether it's a pet, whether it's a kid, whether it's an adult, we can actually do those things. We do those things, and by adding that on top of our Wi-Fi connectivity technology. So the way it's done is by actually looking at a physical phenomena called the Doppler effect. And I'll give you a kind of a very short introduction to Doppler effect. When I'm walking now, you can see that various parts of my body are moving, right? My hands, my legs, my arms, my fingers. Each of them is moving at a different speed. And when the Wi-Fi waves or radio waves are hitting my body or the different elements of my body and are then reflected back, each of the reflections coming from a different element of my body is being manipulated slightly differently by my body. This is called the Doppler effect. And when you're analyzing those reflections and those different manipulations done by different elements of the body, you can see that different behaviors or different things a person can do or a pet can do are actually generating different phenomena when analyzing their Doppler effect. So it's pretty substantial, and when you're applying some machine learning algorithms on top of that, you can literally come to pretty conclusive decisions about whether a person is walking, falling, running, sleeping, and so on and so forth. In terms of use cases, it's actually quite interesting, quite substantial. The same home router, the same Wi-Fi device at home, can all of a sudden count how many people are in front of the TV and even differentiate whether it's person A or person B. You can count how many people are in different meeting rooms inside an enterprise application, for example. You can do some things like detect elderly people, senior people falling within the home. You can do motion detection to turn on and off the light and the heating based on people getting into rooms. You can detect whether kids are at home, whether pets are at home. You can do, I think I lost, okay. So I was getting to the finish, and just the thank you slide, so it's missing, but thank you very much. And if you have any questions, happy to take them after the show.